All right, what is the restoring force for a spring? Where is its equilibrium position located? Here is what the restoring force is. The restoring force is caused by displacement from equilibrium and the spring strength. So however strong the spring is and how far away from equilibrium you are. And there's lots of different causes of difference from equilibrium, the mass that you put on the end, how far you stretch it, all that kind of stuff. And then I drew kind of a diagram here to show you that the spring stretches out because of gravity and a balance with the force there from the spring. So again, restoring force is caused by displacement from equilibrium and spring strength. All right, number 2. Which of the following affects the period of a spring? Why or why not? So the first thing that we were checking was spring constant. We said spring constant was inversely proportional, and the reason is all springs have different strengths to move the mass. So some springs move mass easier because they're stronger. Some springs move mass harder because they're weaker, or with more difficulty, I guess I should say, because they're weaker. So depending on what the spring strength is, depending on what the spring constant is, it'll depend on what the proportionality is. But it's always going to be inversely proportional, which inversely proportional means if the spring constant goes up, the period goes down. So spring constant K goes up, the period capital T goes down. Okay. Second thing we tested, mass. We said mass was directly proportional because more mass is harder to move, so that's inertia, without having more force. So in the pendulum lab, more mass had more force because gravity pulled on it more. Gravity pulls on this more, but that doesn't always help a spring, right? If gravity is pulling down when the spring is down, that's going to work against what the spring is trying to do in going up. So more mass is harder to move without it actually giving more force. So objects that have more mass are going to be harder to move for springs than objects that have less mass. And again, directly proportional means if you increase the mass, you increase the period. All right, third one. Acceleration due to gravity. This one we did not test in the lab. This one we're just going to talk about. Restoring force depends on the spring, not gravity. So gravity does not have an effect. So if you were to go into space and do a spring, it would work the same way as it does on Earth. Springs do not behave any differently if the gravity changes. Gravity doesn't have an effect. And the last one here, amplitude does not have an effect for the same reason it did not have an effect with pendulums. More displacement means more force to compensate, or you can think of it as more energy too. So the further away you are from equilibrium, the more force there is to get you back to equilibrium. So increasing spring constant will decrease your period, so it will take less time. Increasing your mass will increase your period, meaning it will take more time. Changing gravity will not have an effect, and changing amplitude, how far you pull it down, that will not have an effect. So the further you pull down something, it'll go at this. It'll just move faster to make up for that. But increasing the mass, it won't be able to move it as quickly, and increasing the spring constant will mean it can move it more quickly. Last thing on the front page. So on the springs, on pendulums, we talked about what happens to the velocity. That's a little better. We talked about what happens to the velocity. The same thing happens with springs. So springs act with the velocity the same way pendulums do. So what happened with pendulums is we had a zero velocity at the maximum amplitude. It sped up as it got closer down to equilibrium. At equilibrium, it was going as fast as it could. As it went away from equilibrium, it slowed down, and then went to zero at the other amplitude, and then it would repeat again. So that's what happens here with springs. And I went ahead and just labeled the 5 different spots, A, B, C, D, and E. And you can see the velocity, how it changes over time, which is the same as pendulums. Behaves the exact same way. As you're finishing up the diagram, anyone have any questions on anything on the front about how springs work? Yeah.
Just what I'm saying in red.
This here?
Yeah.
Same as pendulums. So whatever, the way that pendulums behave, it's the same way as that. Which is to say, starting at zero, increasing speed, max, decreasing speed, zero again.